Hello all, welcome to the fourth session of the SAT series. In this episode, we're going to talk about the complex numbers, right? But before we get started with the actual questions, let's understand a little bit basics about the complex number and why it is coming into picture, right? So, we have discussed in the past that the square root of a negative number is not defined, right? That's what we keep saying. Well, that's a little bit of an incomplete statement because the square root of a negative number is defined but not in the real world, right? And that gives the birth to the complex numbers. So essentially what we are saying is that the square root of negative 1 is defined in the imaginary world, and this is represented by I. So that's the definition of the imaginary number I, which is equal to square root of negative 1, right? Now when we take the square of both the sides, it will give us negative 1 is equal to I square, right? So essentially I is equal to square root of negative 1. That's by definition of I, and hence I square is equal to negative 1 because we are squaring both sides, right? Now let's understand how do we represent a complex number. A complex number is represented by a plus bi, right? So this is our complex number. It has two parts. This is the real part, a, and this is the imaginary part, right? So essentially a complex number has two parts, the real part and the imaginary part, right? Now it is very much possible that the real part is 0. Let's say a is 0, right? As long as we have the imaginary part, it will still be a complex number because this is the part which is making this whole entity as a complex number, right? Now that we understand a little bit about the definition of I and how do we represent a complex number, what are the two parts of the complex number, real part and imaginary part, let's talk about one more term which is called as the conjugate of a complex number. So if we have a complex number a plus bi, right, the conjugate of this complex number would be a minus bi. So essentially what we do for finding the conjugate of a complex number is that we change the sign, we flip the sign of the imaginary part, right? Whatever is the sign of the real part, we keep it as it is, right? We just flip the sign. If this is plus, this becomes minus. If this is minus, it becomes plus, right? So for example, if you have a complex number minus 2 plus 5i, right? So the conjugate of this one would be minus 2. We're not going to do anything to the sign of the real part. We'll just keep it as it is. We'll just change the sign of the imaginary part. So it will be minus 2 minus 5i. So minus 2 minus 5i is the conjugate of minus 2 plus 5i. Let's start with some basic questions. Square root of minus 25. We can write it as square root of 1 minus 1 times 25, right? Which is again writing the same thing as square root of minus 1 times square root of 25. Square root of minus 1 is I, as we just saw, and square root of 25 is 5. Hence, the value of square root of minus 25 is nothing but I5 or 5i. Typically, we write it as 5i, right? Let's move on. The value of I to the power of 44, right? Now, we just saw that I is square root of minus 1 and I square is minus 1. So we can just try to write it in terms of I square, right? So I square to the power of 22, right? Because the powers get multiplied, right? Now I square is negative 1. So negative 1 to the power of 22. Since it's an even power, so negative sign will go away and we will be left with only 1. So the value of I to the power of 44 is 1, right? Let's move on to the third one. Again with the same logic, the square root of minus 36 would be nothing but 6i times square root of minus 64 would be 8i. I'm referring what we have done in question 1. So this will become 48i square, and I square itself is negative 1, so it becomes 48 times negative 1, or essentially negative 48. So square root of minus 36 times the square root of minus 64 is nothing but minus 48. Let's go back to our original question wherein we had to find the real part of this complex fraction, right? So to start with, we will find the conjugate of the denominator, right? So let's say the denominator's conjugate would be 8 minus 2i, correct? We just flip the sign of the imaginary part. That becomes the conjugate of a complex number. We are saying we have to find the conjugate of the denominator, which happens to be 8 minus 2i. So this is our given fraction. We are going to multiply the numerator and denominator by the conjugate of the denominator. So 8 minus 2i, 8 minus 2i, right? We will see why we are doing so, right? So if we have a fraction, we can multiply the fraction, the numerator and denominator by the same number, by the same entity, correct? So we did that. And if we see the denominator, right, it is 8 plus 2i times 8 minus 2i. Now if we remember the difference of squares, right, 8 plus b times a minus b is equal to a square minus b square, right? And the denominator falls into this category, right? 8 plus 2i times 8 minus 2i. So 8 becomes our a and 2i becomes our b, and we can actually utilize the difference of squares here, right? When we do that, we get a square, which is 8 square, which is 64, minus b square. Now b is 2i in this case. So b square would be 4i square. So 4i square, correct? All we have done is use the difference of squares for the denominator, okay? And let's do the FOIL method and multiply these two terms on the numerator. So 3 times 8 is 24. 3 times minus 2i is minus 6i. Minus 5i times 8 is minus 40i. Minus 5i times minus 2i is plus 10i square, right? Plus 10i square. Okay. Now I square is minus 1. So 4i square becomes minus 4. Minus of minus 4 is plus 4. So it becomes 64 plus 4, right? Let's combine the like terms here on the numerator. So minus 6i minus 40i becomes minus 46i. 24, let's keep it the way it is. So 24 minus 46i and plus 10i square. I square is minus 1, so it becomes minus 10, right? And this becomes 24 minus 10 is 14. 14 minus 46i divided by 64 plus 4 is 68, correct? And then we can break down into two different terms here. 68, right? So finally, by doing all of this stuff, we are able to reduce the given fraction in terms of a plus bi, right? And a is the real part. So the real part for this would be 14 over 68. Obviously, we can simplify it. So 14 over 68 will become 2 times 7, 2 times 34. So 7 over 34 is the real part of this fraction, right? Just to reiterate what we did, we multiplied this complex fraction by the conjugate of the denominator, both at the numerator side as well as the denominator side. And the reason we did that was that because once we do that, we realize that we can use the difference of the squares here at the denominator side, and eventually we get rid of the I from the denominator, right? Eventually we get only a real number here in the denominator, and hence we can break it down into two terms. So that's how we solve any question like this, wherein we have to either find the real part or the imaginary part. Hopefully you guys got a good perspective in terms of what is a complex number and how do we deal with questions related to complex number. If you have any questions, please do feel free to reach out to us at info.mathleads@gmail.com. See you in the next session.